Hello and a warm welcome to today's webinar on From Data to Action, Science and Solutions for Marine and Riverine Plastic Pollution. I'm Akanksha Singh, the community builder at Be Waste Wise, and let me give you a brief intro on our organization. We are a non-profit organization bridging the global expertise gap worldwide for over 10 years for over 120 countries. Uh, if you see the value in making such diverse sustainability dialogues such as these, then we request you all to please visit our page and donate. Uh, let's make these discussions available free of charge to anyone and everyone and support us in our mission. We encourage you all to please check out our website and donate. We will also share the link to the donation page over the chat as well. Moving on, I also want to thank you all for joining in and giving us such strong response to this session, and which clearly reflects how urgent and relevant the issue of plastic pollution has become. Plastic pollution is no longer such an environmental concern. It is a systematic challenge impacting ecosystems, human health, and livelihoods. And in the Indian context, rivers play a critical role as conduits, carrying plastic waste from land to sea, often due to gaps in waste management, high consumption, and limited segregation at source. But there's also a powerful opportunity here. By combining data, science, and technology, we can better understand how plastic moves through our systems, and more importantly, how to stop it. Today's session brings together diverse expertise to explore exactly that and how we move from understanding the problem to implementing scalable real world solutions. Moderating this session today, we have Kaushik Chandrasekharan. He's the Assistant Program Management Officer, United Nations Environmental Program. Kaushik is a waste management and source efficiency professional with over 15 years of experience across policy advocacy, research, and on ground implementation. Along with Kaushik, we have an eminent lineup of speakers. We have now, who's a program management officer, UN Environment Program. We have Dr. Chandrasekhar, who's a managing director of Alphamers and Beta Chronobotics. And we have Dr. Girija Bharat, who's a managing director of Mugama Consultants Private Limited. We've also shared the LinkedIn profiles of our panelists over the chat as well, so that you can feel free to connect with them individually and personally. Before we proceed, I would like to make some announcements and important, discussion points that this webinar is being recorded and will be uploaded on our website and YouTube channel. Please use the Q&A function for all your queries to the panel, and also the chat function for sharing your views and opinions, some reports and insights related to the topic for networking purposes. Please request you all to please use these both functions separately. We tend to miss out on a lot of Q&A, lot of queries from your side in the chat. So we request you to please use the Q&A function for all your queries. So back to the panel and over to you, Kaushik sir.
Thank you, Akansha. I hope I'm audible.
Yes, clearly. We can all vouch. Yeah.
Thank you once again, Akansha, and welcome once again to this webinar on From Data to Action, Science and Solutions for Marine and Riverine Plastic Pollution. As we all know, and as Akansha mentioned earlier, plastic pollution in rivers and oceans have actually become a major environmental challenge across the world, which includes India as well. Very often, we end up speaking of marine plastic pollution with a focus preliminarily on oceans and coastlines. But the larger part of this issue actually begins much earlier within our cities, be it our drains, lakes, rivers, and like Akansha, mentioned, a lot of gaps in our collection systems, the way we segregate our waste, littering, and also poor waste management. We find various contributors actually, pooling in these plastic waste into the water bodies and eventually into the ocean. To address this, problem effectively, I feel that we first need to understand the problem better. where plastic leakage is happening, what kind of plastics are actually entering these systems, and how they actually move and traverse across, what are the impacts that they are creating. And this is where I feel that data and science, combined with technology, all have actually become very, very important and are closely interlinked. We've tried to connect these dots as far as our discussion, is concerned today, to kind of bring all of these different perspectives. We'll first look at the role of data in helping us understand and track plastic pollution. We'll then move on to the science around it to understand, especially from the Indian context, what is actually there as a part of the waste that gets ended up there. Finally, we'll move on to discuss technologies which are locally relevant, practical solutions that can actually be implemented at the urban local body level, at the rivers, the water bodies, to kind of intercept these streams of waste before actually it reaches the ocean. And we have an excellent panel of speakers with us today, and I'm very, very excited to and look forward to the insightful discussion that we have in store. I feel a good place for initiating this discussion would be with a broader global picture, particularly to understand how data and knowledge platforms have actually been helping us to understand plastic pollution better. For this, I'll come to you now. Let me kind of begin with you. And if you can please tell us a little bit about GPML, the Global Partnership on Plastic Pollution and Marine Litter, and also the Global Plastics Hub. Maybe to kind of understand this better, you could also tell us about some trends of plastic flows globally and how leakages are kind of being visualized as a part of this hub. Now.
Thank you so much. I'm just wondering if the presentation that I shared with you can be shared by you, or should I share it from my side?
You can share it from your end. And
okay, let me just open it. So while I'm preparing this presentation, my name is Nao Takeuchi, and I'm a program management officer from UNEP, who are working on the development of the Global Plastics Hub under the framework of the Global Partnership on Plastic Pollution and Marine Litter. And I'd like to make a short presentation about it. How I cannot. Yeah, I can share my screen. I don't know how this would work. Share. This one, yes. Can you see my screen?
There is something coming up now. Just a moment.
Yeah.
Yes, we can now see it. You can put it on full screen.
Oh, how can I switch this one?
This is fine. I think we're able to see it.
This is okay?
Yeah.
You can see? Okay,
yes.
So Global Plastic, I'd like to first introduce about what the Global Partnership on Plastic Pollution and Marine Litter. This is created based on the UNEA resolution 46 basically, and then this is the largest global multi-stakeholder partnership addressing plastic pollution, marine litter, and UNEP is providing a stakeholder as secretariat services to this partnership, and we are driving the coordination and collaboration among the different stakeholders for the effective and efficient actions to tackle the plastic pollution. And then under this Global Plastics GPML, Global Partnership on the Plastic Pollution and Marine Litter, sorry, this is a little bit mouthful, but we developed the Global Plastics Hub as a kind of a platform for the coordination among the different multi-stakeholder coordination between stakeholders and also driving the multi-stakeholders actions. This is mandated by, again, UNIA Resolution 46 and 515, and then this is the largest open source crowdsourced platform on plastics. And then this is like one-stop shop for providing data, knowledge, and expert networks. And then we connect stakeholders, integrate data to coordinate action, and also for, most importantly, for the evidence-based decision-making and policy-making for plastic pollution. And this is how it's looking like. You can scan this code to get connection to the Global Plastics Hub. But the Global Plastics Hub has 4 different pillars. And one of the first pillar is called Knowledge Hub. And then we have library and then also learning center where you can get an access to technical resources, good practices, case studies, guideline tools, training courses, and so on. And then once you become a member or register to this platform, you can also upload your own report into this library. So it's a really great platform for you to showcase your reports and knowledges and so on. And then we have also a data hub. Sorry, this is 80, but it's now about 70 plus indicators from global data sets across the plastic life cycle is visualized. And the community we have at the moment 2,800 plus stakeholders and experts are connected and registered to the Global Plastics Hub. And then this is the place for you to really like network with relevant stakeholders, the subject experts and so on. And then once you get registration and then you are registered as a representative from country, for example, and then you can get an access to action planning tool, which is a step-by-step guidance for countries to develop evidence-based national action plans, and the strategies are supported. And just quickly showcases how the Global Plastics Hub is looking like. So this is the data hub, which is most important, one of the key functionalities of the Global Plastics Hub. So we publish the global data sets on global plastic trade, waste management, and plastics in environment, coming from various data sources. And then we have global map as you can see on the left side, and then also the country dashboard. So you can also go to the different countries and then see the trend of the global of the country's plastic flow in your economy and also in the environment. And then country dashboard is also looking like this. You can see we are also updated some of the country dashboard as a pilot for these countries. And then India is included in there among different countries. So maybe you can have a look at it. And then if you have any insights and information, please feel free to reach us to showcase. So maybe I can just stop here sharing this one. And then I think, Kaushik, your question is about the global trend and what the data tells also. Yeah, about the plastic leakage from those data, right?
That's
so
correct.
we collected a lot of data from like trade and waste management, and then in plastics and environment, such as SDG 14.1.1b, particularly on the beach litter data. And then through like screening that into different countries, we started having like the insights on the global and then also country level. So what, for example, that plastic trade data tells at the moment is that the total amount of the plastics, not the amount of the total value of the plastics being traded has been doubled in the past 2 decades globally. And then it became up to 1.2 trillion US dollar per year, which is a representative of 5% of the global total global merchandise trade. That's one thing. And then what are the key drivers for this big increase, for the incremental increase of our consumption of the plastics in the past 2 decades is we can see like prominent increase in packaging and packaging in the textile industry. So traded textile has been really more than doubled for the past 2 decades. So these are key drivers, and are particularly driven by the industrial expansion for export and also domestic consumption in developing countries. That's a really interesting perspective that we found, particularly in India. The plastic consumption, which is basically import minus export, in the past 5 years, from 2017 to 2023, it's almost quadrupled. So it really showcases that the consumption of the plastics in India has been increased. And then when you look at the top categories of the what plastics is being exported from India, for example, is very prominently textile, and then packaging as well. And of course, this is a reflection of the domestic consumption style, and then also industrial expansion. We can see the similar tendencies in Cambodia, which experienced the exported textile. The most majority, 90% of the plastics being exported from Cambodia is actually textile. So you can see that the Cambodia being kind of fast fashion hub, and then creating lots of jobs for those people who are in the textile industry. And then that is also reflected and this is mirrored by the amount of, for example, the microplastics found in the Mekong River. And then the microplastics found in the Mekong River, like most commonly found items in the Mekong River is fibers and fragments. So this, like, you really can see that like kind of correlations between the industrial, the trade data, and then also the environmental data talking to each other somehow when you look at the country level. That's one thing. And one thing that might be interesting when it comes to leakage, there's one study done by the University of Leeds, and then that was published in 2024, which is basically the result of the modeling, tracking the plastic waste flow coming from the municipal solid waste in the granularity of the municipal level, and then estimated how much plastics emitting to the environment, including debris, and then also open burning. And according to the study, we found out about like 552 million tons of plastic waste is emitting, released into the environment in the form of open burning, and then also uncollected waste. This is only coming from municipal solid waste stream. We don't really look into different types of like emission sources because we don't have much of like information about it. But this is a comprehensive study on really focusing on the plastic leakage coming from municipal solid waste. Tells a lot about how our society really deals with plastics. For example, so 52 million tons per year of plastics emitting into the environment coming from municipal solid waste management system globally, is almost one fifth of the total plastic waste generated from municipal solid waste management. So like, let's say 20% of the plastic is going into the environment. And an interesting driver of that, what's the main sources of this, is uncollected waste. So when you look at the more interesting, like this is also like validated by the UNEP's Global Waste Management Outlook, which estimated about 2.7 billion people do not have an access to formal waste collection service. And then why is it like that? Because simply waste collection and waste management is expensive. You need to pay the fuel, you need to maintain the truck, you need to run the facility, and then bring it to landfill site. And then even to landfill site, to operate it, you need to pay money to, those things all cost money. And the majority of the people, for example, like just earning every day like less than $5. How can those people pay for that? It's impossible. And then do municipal governments in the developing countries or global south, measure to global south, do they have such kind of municipal finance? And that is really lacking. And how to really fill that financial gap is the question. And then how the EPR system, for example, extended producer responsibility system, can fill that financial gap is something that we should really talk about to address this massive source of plastic leakage. So maybe I can stop here. I started talking a little bit too much, but those are the overall insights that we have at the moment through the development of the Global Plastics Hub.
Thank you. Thank you. Now, firstly, for the clarity on what is the GPML and how the hub plays a role in all of the insights that you provided. Also, what was interesting to learn was the range of resources that it offers to the practitioners, including the country dashboards and the action planning tool that you spoke of. Interesting insights on the consumption patterns and also the way waste is being disposed. Which brings me to the question of what. And for this, let me come to you, Dr. Girija. We know that waste is leaking. There is a leakage that's happening. The next question that comes to us very naturally is what is leaking? And from a science perspective, what evidence do we have with us to tell us about what type of plastics are there in the environment? And what kind of plastics are prevalent in the Indian conditions as far as the marine and riverine systems are concerned? And importantly, how does the data kind of reflect this? Over to you, Dr. Girija.
Thanks, Kaushik. Thanks for asking that question. It's very, very pertinent. And we often ignore the importance of data in some of the metrics where it is urgently needed. So in this regard, we, as now just mentioned, that the society's, in ways, the footprints of society's lifestyle is reflecting in the solid waste generated, the plastic waste that is generated, and how it gets transported downstream. So in this regard, we did this study, Indo-Norway cooperation project on capacity building for reducing plastics and chemical pollution in India. We did it in Gujarat, basically the Tapi River and the Damanganga, these two rivers. And recently we concluded the Kaveri River. So here we are developing coherent systems for data collection and analysis. And the results which we got was very, very, it was eye-opening and really useful for policy implications. We have done this study of quantification to understand what kind of polymers are there, what shapes are there, what colors are there. So primarily we found that polyethylenes are very, very high, around 48 to 50%, followed by polypropylene and PET and polystyrene. So polypropylene is also something like 35%, which is also quite high. And PET is something like 11%. And polystyrene is about 6%. So this is what we got from Tapi River quantification study, which we did. We similarly did for Kaveri, and the results were quite aligned. And we also have brought out some of the policy strategy reports for both the states of Gujarat and Tamil Nadu, which has been shared with the respective state governments for policy action. So we have seen in our research that we often have data, but then we don't bring it to use. And as macroplastic, they are visible component of the plastic crisis, and microplastics are its systemic expression. So while we know what kind of macroplastics we are generating and how it is the apportionment of it, and how it is leaking down to the river and through the rivers to the marine ecosystem. So if you allow me, I would like to share a brief film about how we did the sampling and what all were our findings. Just give me a second, please.
Sure.
The catchment of the Kaveri River, originating in the Western Ghats. The river spans approximately 800 kilometers in length and flows eastward through the states of Karnataka, Tamil Nadu, and the Union Territory of Puducherry before discharging into the Bay of Bengal. This map shows the Kaveri River catchment within Tamil Nadu and the 6 locations selected for macroplastic sampling. This catchment-based approach allowed us to capture spatial variations in macroplastic inputs and transport processes across the river system. Across 6 strategic locations, a multifaceted monitoring protocol was deployed. By synchronizing visual surveillance, net sampling, and riverbank survey, the study captured the full spectrum of macroplastic dynamics, whether buoyant, suspended in the flow, or deposited along the banks. Our preliminary INOPOL findings show that dominant categories of macroplastics seen across the methods comprise plastic bags, often with contents, food packaging, sachets, and cleaning, cosmetics packaging, which is likely derived from household waste. The total proportion of SUP items, excluding plastic bags, was 2.4%, indicating relatively satisfactory compliance with the ban for non-carrier bag items. Sampling for microplastics was conducted in 2 contrasting seasons. In February 2024, 13 sites were sampled under low-flow dry conditions from upstream to downstream to the river. In November 2024, 6 bridge-based sites were sampled. After field sampling, river water samples were transported to the laboratory for microplastics extraction. Before starting the procedure, strict quality control measures were followed by wearing nitrile gloves and laboratory coats, and thoroughly cleaning all glassware to prevent contamination. The extraction process was carried out following the ISO 24187 protocol. First, the water samples were sieved to remove large debris. A saturated salt solution was then prepared for density separation. The sieved samples were transferred into a separating funnel containing the salt solution and left undisturbed overnight, allowing plastic particles to float to the surface. The floating fraction was subsequently collected and filtered using vacuum filtration. Silicon filter papers were used for microfilter analysis, while glass fiber filters were used for GCMS and optical microscopy. The filters were then oven dried and prepared for further analysis. Optical microscopy identified 5 microplastic shapes, fibers, fragments, films, beads, and pellets. Most microplastics were in the 500 to 1000 micrometer range in both seasons, while white and blue particles dominated in the dry season. The pie chart shows site-wise microplastic abundance across 19 locations, ranging from 0.52 to 6.16 particles per liter. Micro-FTIR analysis identified polyethylene, polypropylene, polyethylene terephthalate, polystyrene, and polyamide as major polymers. Scanning electron microscopy revealed clear signs of environmental weathering on microplastic surfaces. The PYGC EMS chromatograms show characteristic profiles of major polymers such as PET, polystyrene, and polyethylene by their degradation products. Micro-Raman analysis confirmed polyethylene and PET, supporting the FTIR and GCMS results. Ecological risk was assessed using the Polymer Hazard Index, which classified all sites under Hazard Category 3, indicating moderate but persistent risk in the Kaveri River.
Thank you.
Thank you, Dr. Girija. I think that was very, very insightful, and your observations on all the rivers and the assessment, Tapi, Damanganga, and Kaveri. I think what was also interesting to note was the catchment-based approach that was taken into account,
Yes.
and
indeed.
also the findings in terms of carry bags being a perennial issue, which is often the pain point for at many cities. I think this is very, very interesting. Thank you. So with this, we understand that there is data that backs leakage. We understand what is being leaked into the environment. Now we go on to how do we kind of address this? And for this, I come to you, Shekharji. If you can kind of walk us through the technology that you have worked with, especially deploying them on water bodies, and what kinds of waste streams that they are most effective at kind of capturing. Over to you, Shekharji.
Thank you, Kaushik. I'm not a Dr. Shekhar, by the way. I'm Captain Shekhar. I'm an ex-merchant Navy captain. Okay, so we got into the job of arresting plastics. It was driven by simple desire. I wanted to see clean water bodies around me. But today we have traveled far down that line. And let me show you what we started with and what we thought and how we have reached. So I have some slides. I'm sharing the slides. Give me a minute. You can see my slide?
Yes, you can put it on full screen so that it's visible. Yes.
Yeah.
Perfect. Yes. Now
Done.
it's okay.
Okay. Now, before starting, we just analyzed what happens to a wrapper when somebody throws it. Maybe it's fallen from his hand, whatever. The first rain invariably takes a discarded wrapper into a nearby drain. And from there, you can see the second image into a stormwater drain, then onto a small river, and to the open sea. Once something big happens between the river and the open sea, this long unidimensional journey, single dimension journey through the drain, stormwater drain, through the river, once it crosses the river mouth, now it spreads over a two-dimensional sea surface. After some months and perhaps years of being beaten by the waves, it breaks up into microplastics, and a lot of that goes down the water column. What we thought about was intercepting this when it's in this long unidimensional journey. That's the best way to address the problem. We do not want to know where is the plastic concentration. You put your installation here. It's a passive installation, and the flowing water of the river will bring it to where you are going to collect it. You don't need a boat. You don't need a fuel to empty that boat. Nothing of that sort. The river current does the job for you. So that's exactly what we did. Today's technology, I know there are some attempts at cleaning the ocean surface. I still don't call it scalable until we start using renewable energy for that, ocean energy, because the distances are very vast. As of today, what goes down the sea, the water column, is going there permanently as of today's technology. Perhaps 2 generations from now, they might be able to extract and clean up the bottom of the ocean. But today, we can barely think about cleaning up the surface of the ocean. We started in 2016, and we did something at that time which is relevant even today, and we still do that today. 2 principles of the design. One is we always install it diagonal, so that whatever hits this barrier, it slides and goes to that corner between the river bank and the diagonal barrier. And we are picking it up from the river bank. How does that help? That we don't put an expensive boat in the middle of the stream, pick it up, and then use other fuel burning boats to bring it to the same river bank. It just slides and reaches the corner there. So that's something from 2016. We have been doing this. This is not an image from 2016. I'll show you other Google Earth images. Whatever we have installed is visible on Google Earth. On the right side is another principle which we have followed from that time, is a very low drag force. A drag force is something when you put your finger in flowing waters, the force that your finger feels, that's a drag force. We allow the maximum water to go past and only arrest the macroplastics. How does this help? Is that we are able to put long barriers, very long barriers, the longest barriers in the world The first and second is done by us because we could reduce this drag force. These are all design, I believe, is 90% inside the head and 10% on the shop floor. These are all things that intuitively one can close your eyes, imagine the design, and that's how it pans out. Now, this was 2018. Kuam River, the image is from Google Earth. You can see on the left side, the water is actually flowing from this bottom of this page, from the screen to the top. And as expected, it hits the barrier. This is a floating barrier. It all comes to the corner. Wherever we install, we make sure at the downstream end, it's accessible by trucks. Because when we install this barrier, within half an hour, it starts collecting. And in this case, it was 21,665 tons of trash that got collected in 1 year, 10 of them in that river. This I'm talking of 2018, full year of operations. At that time, I think this is more than what the rest of the world could manage to collect. And without using a drop of fuel, because the river flow brings it there. Now, to pick up from the river bank and put it on a vehicle, we still need fuel. I'll just show you one very short video. It could be interesting. That's a Google Earth image. I'll stop for a second here. Now, this is on the coast. This is Chennai. This is on the coast. And typically on the coast, you have the tidal movement, flood and the ebb tides. So what gets neatly collected in the corner during the ebb tide, in the next flood tide, it is again dispersed upstream. So the contractor who's removing from the water and taking it away, he normally comes with one earth moving JCB and some 6-7 trucks. He was complaining that every day I have to come a little later because the tidal cycles don't exactly coincide with solar cycle. It's 1 hour later every day. So he had to come. So if you see the other side is a straight line. We adapted to that, put another barrier so that when it comes, it gets trapped and he is able to do that. These are simple, innovative solutions that we adapt all the time.
Thank you, Shekharji. I must mention that what is interesting is, there is no additional resource requirement, like you mentioned, like a fuel being burnt or power being deployed for this intervention. And we are actually using the tides to move the waste towards the shore. And with this, I think we are, the particular intervention is, not working in isolation and, depending on other external fuel. So, what this brings us to is to understand that, all of these technologies will not work in isolation, and its effectiveness, of course, will depend on, the waste flows, hotspots, and also the leakage pathways, which brings us back to the importance of data and, decision support systems. I'll come to you now once again, to kind of understand, and if you can tell us how the Global Plastics Hub is actually informing, decision making on the ground, especially working with, governments. And are there examples that you can speak of where, data has actually directly influenced policy interventions taken? Over to you now.
Yeah, thank you, Kaushik. So the data is very, very important part to really inform the policy making and then also implementation of any actions. I think I can really draw some of the experience for like collecting the municipal solid waste data back in the days, 2021 or something. We conducted the data collection on solid waste management, particularly with a focus on plastic waste flow in Lagos in Nigeria. And then there we found out about, like, our estimate was about 39 kg per person 34 kg per person per year, a plastic is going into the water system in Lagos. And that is equivalent to every single person in Lagos is throwing 10 water bottles into rivers every single day. So that came as a very big surprise. And then we checked because that could be an outlier. It's the data, there's something wrong with it, and so on. So we checked. But considering the geographical characteristics of Lagos, which is delta, and then also many people do not have an access to waste collection service. On top of that, we recorded very, very high plastic composition in the waste stream, which is reflecting mirroring the consumption style in the people in Lagos. Where they use a lot of plastic packaging for the street food culture. So that just goes into rivers and everything, going directly into the rivers and oceans. And then we submitted that based on that data, we made our recommendation saying that let's ban this street food container that everybody's using. That's first one. And the second one was a high textile concentration because that Nigeria reopened the second-hand clothes imports coming from the Europe and then the United States. So that's also second policy recommendation. And then immediately after that recommendation, the state government of Lagos took it seriously, and then they started, and the next year they enacted this single-use plastic ban, specifically focusing on the street food one, because I think that was the data showed in there was really matching the experience over there, probably. So that's what's the one example that I would say the data really driven the policy making and actions. Another example is in Mombasa. So the GPML and together with the UN Habitat, we collected the data in Mombasa back in the days on the waste management, and then we estimated the waste collection rate about 56% and so on. So those data was submitted together with the sets of policy recommendations to the government of Mombasa, the county government of Mombasa, and they took it very seriously. And then that really informed a lot of actions followed by them. So that the government of Mombasa used those data for the fundraising, for example, coming from WWF Coca-Cola Foundation to set up a MRF, particularly focusing on plastics. And then the number of just transition project registering those informal waste pickers and so on. And then those activities also led to, and then also the data was widely used to create a project, large holistic comprehensive waste management improvement project in Mombasa by the European Investment Bank. I'm not so sure if they are going to really finance that because there's lots of screening for the bank side to release the fund and so on. But as far as I know, that the JICA has also started looking at the Mombasa's project development. So data is always catalyst for inviting the investments and then inviting projects, both from the grants, both from the investments and so on. So I would say that data is quite a catalytic part for driving the actions, particularly evidence-based actions. And evidence is always needed whenever someone wants to invest in somewhere because they want to get the money back.
Thank you. Now, interesting insights with this experience in Lagos. Like you mentioned, I think data makes it so much more easier for stakeholders to take action and also, for example, get investment, back it up for actions to be taken. Also wanted to mention the interesting insight on the ban on disposable street food containers. That was also a good insight. Thank you now for that. just taking this dialogue a little bit towards microplastics, I wanted to come to you, Dr. Girija. We understand macroplastics well, now spoke of the trends that we are seeing with cities. When we talk of microplastics, they're often, less visible to us than the macroplastics. You spoke of, the various testing methods, the lab, processes. Are we kind of understanding this issue enough, or are we kind of underestimating the scale that we have at hand? Especially when we look at the Indian context, the range of rivers, the range of water bodies that we have, how confident are we in kind of attributing sources to the microplastics that you just spoke about, especially in your experience? And if we have to kind of go back and say that this is where they have originated from, so that policy can kind of focus on these aspects. Over to you, Dr. Girija.
Thanks, Kaushik. As I was showing a glimpse of the Innopol project, we have done this project in Tamil Nadu, Gujarat, and now planning to do it in Odisha. So the findings were quite aligned in some aspects, and then they were quite divergent in some of the aspects. So we know that microplastics origin from different sources, but unfortunately, our current regulatory framework, be it EPR or PWM rules, it focuses primarily on collection, recycling, and end-of-life management of microplastics. And our research analysis suggests that microplastics are not integrated into the policy design. We have all seen that, particularly in terms of upstream control, that is product design, be it textile standards or micro bead ban enforcement or whatever, which is related. And downstream monitoring is also not happening that well. So except for few projects here and there, there is lack of downstream monitoring generally. And research has indicated that textiles, tire wear, and packaging are some of the sources. However, it does not yet have high confidence source attribution for microplastics. So a country-specific data to quantify these relative shares due to gaps in monitoring systems do exist, and standardized methodologies are also, there is a challenge and gap area. And these instruments are very, very expensive. So the laboratory capacity is limited, and very few laboratories have it, very high-end instruments. And even in places where we have seen that there are instruments, these very high instruments, but the capability of handling this instrument is not there. In some of the places, we have seen that the monitoring is happening, but not in a very concerted manner. So there are challenges, and India lacks robust country-specific data to quantify their relative shares due to these gaps. Our existing frameworks like the Plastic Waste Management Rule and EPR, they target packaging waste, especially low value and multi-layered plastics that are prone to fragmentation, and issues through stricter regulations for biodegradables and microplastics need to be there. There's definitely growing recognition, and we know that wastewater system sludge also often recirculates it in the environment. The sludge, it's collected and used for agriculture or other uses, and it does recirculate it to a large extent. Our approach for microplastic should be precautionary and can focus on basic definition of microplastic comprehensively to cover all forms. That is, it should cover microbeads, fibers, etc. And we need to have standard for microplastic in different matrices such as air, water, soil, biota, food, etc. And mandate product labeling and transparency. Yeah. We are missing out on discussing about industries. I was glad to see one of the questions which was on industries. We should regulate industries with reduction targets and controls. Otherwise, we are only working on one side of it, one segment, but the industries are definitely hit by the single-use plastic ban, but we need to have regulation more stricter. In Tamil Nadu, we were very happy to see that the single-use plastic, the periodicity of the macroplastics had really drastically reduced. So when we gave this important information to the Environment Secretary of Tamil Nadu, they were really happy that, oh yes, that shows the effectiveness of the ban, the single-use plastic ban, which we have given. Yeah. We also are often blind towards this intentional microplastics, like the beads in cosmetics, and there is a lot of greenwashing going on, which has to be regulated, and we need to have strict norms, and we should ensure strong enforcement with compliance, penalty, and possibly incentives for industries that are complying. Yeah. I hope I answered your question.
Yes, Dr. Gareja. Thank you so much. I think the important point you make there is the policy angle, which is very evident. And also you speak of harmonized and standardized methodologies, which is also very, very critical, because if you're going to have different methodologies being used across the world, you're going to get different sets of data where you're not able to, kind of correlate each.
Absolutely. We are comparing apples and oranges and it never works.
Absolutely. You also bring out, limited lab capacities and of course the costs which comes with it. A very, very pertinent point. Thanks for that, Dr. Gireja. We will go to Shekharji. Shekharji, before we close, because we are running out of time. But Shekharji, I think I come to a very, very important aspect here. You spoke about the technology that you're kind of intervening with. Many a times the questions that come up with urban local bodies is that for realization of such projects, the cost is something that stands out. From a cost standpoint, what is this technology kind of address, and are there different models with which you've worked on to kind of finance these technologies at the urban local body level? Over to you, Shekharji.
Right. So this technology has been deployed across 10 cities, 45 locations. It's on Google Earth. So people are very quickly, they go through and they're convinced about it. One location costs about $35,000. Average city river of 50 meters. We put it diagonally about 75, 80 meters. That I think is a fraction of the international campaigns. I believe some of them is much, much higher. So the cost is per se is not the issue. How to fund it often is the issue, because I do believe, this is not directly my line of subject, but the plastic that come out of it is not very friendly for upcycling or recycling, and a lot of such issues are there. So it doesn't pay for itself. Plastic credits is there, but I'm not sure how much of plastic will come out from the river, so there's a certain revenue risk. But what we do is CSR funding. CSR funds. There are corporates who have got CSR funds, and they want to see that the area where they are located and they're nearby, where they like to have some influence and goodwill, they like to install this in stormwater drains, all of that. That is one very good way of funding. And yes, plastic credits. I believe the basic model is a very good one. Plastic credit will go to place where there's maximum pollution and lowest cost of removal of that. So in principle, it is a very good model. So these are the two models I see, unless the government is funding or multilateral institutions are funding. Incidentally, we have just done one pilot, the first pilot of a multilateral funded project, and we might be doing further over there. So they give us a certain smooth operation. We don't take donations. We don't have the system of taking donations. And that's why either it is revenue from the urban local body or it is CSR funded. One more point, if I can add, like Dr. Girija was mentioning about samples. Very interestingly, when we installed a barrier in one of the river, next day morning we go, nor whatever is coming, it stops there. It doesn't go anywhere, once it comes there. We had a big patch of yellow in the river in the corner. That is, we went closer and found that they are expired food packets. One of the noodles company it was expired and they had discarded in the river. Before these barriers are in place, they would have just flown past. They would have just gone past. So now the evidence is stopped at the barrier. You can't wish it away, and very soon some of these things stop. Wherever it could be tracked, the labels you could read, and you know that between the previous barrier and this barrier, someone has thrown it in this area. So that makes a collection of sample macro, not micro at all. This is all for microplastics. Thank you.
Thank you, Shekharji, for those comments. We have to quickly move into the questions that we have from our audience. One of the questions that is still unanswered is, could we find more financing from other sectors than the environmental, which is hugely under budgeted? Highlight synergies with health, tourism, etc., to reach further with addressing the waste menace. Anybody would want to go with this?
Yeah, maybe I can give it one part of the opinion.
Yes.
The world has a big appetite for solving problems, and the kind of donations that come from major corporates is quite high. If we show them a technology that is scalably low cost, I'm not saying it has to be cheap, but scalably low cost, I think there is funding available. It's a matter of making the case, telling the people, look, this is what is working, and the funds can come. I'm seeing the international campaign, the kind of money that is generated is quite sufficient to do a lot of. In my opinion, $200 million is what I calculated for the Indian coast. That is, I'm talking of some 200 clusters of 10 of these installations each, and 200 broadly cities and towns on the coast. And that can cover all the plastics leakage on the entire Indian coast, and including certain operating expenses for, say, another 1 or 2 years. So if we keep the cost in handle, the technology seems to be working. There are people who are able to put their hand in the pocket, and people who like to see themselves as plastic neutral. So a beverage company may not have the wherewithal to collect plastics from different parts of the world. Logistically, it's a nightmare for them. So they like to sponsor something like this and call themselves plastic neutral. So there is some space over there. Thank you.
Thank you. And the next question again is on, I think this is a very pertinent question, which kind of looks at EPR for reusable packaging. It says, are there any companies working on reusable packaging for industry in India, since EPR demands at least 10% reusable packaging for producers using packaging of products more than 0.9 liters. Anybody who'd want to go for this? Dr. Girija, maybe? You're muted, Dr.
Yeah,
Girija. Sorry.
I think I should give it a pass, Kaushik.
Sure. So I think this is a question that we will get back to you with an answer on specific companies. We can write to you. We have your coordinates, so we can get back to you with specific companies who are working on reusable packaging, because it becomes a pertinent part of the EPR targets that are there. Just one last question before we kind of close. What is the solution for textile industries to implement? Maybe I think the question is indicated towards the textile waste that we spoke of. Anybody who wants to kind of take this question? Anything that a textile industry could actually implement in terms of a solution?
Maybe I can just jump in here a little bit
Yes,
in
ma'am,
terms
please.
of the textile. It's a really big question, and then like where the alternatives, I think, is something. So in terms of the trade data, the trade data coming from UNCTAD, we used their database under the global plastics quite extensively. And then they have also a data about what kind of alternatives are being traded among different countries. So maybe those data sets can provide us about the solutions for what kind of alternatives are there. through shifting the textile industry into more circular and then also more focusing on alternatives, not really fossil-based materials to be used in their operation, maybe.
Sure. Thank you now for that. Shekharji, before we close, we have one specific question for you. Any info on the types of plastic waste trapped in the barriers that you've come across? Shekharji, please.
Yeah. We have a lot of surprises. Anything that floats is how I now define it. We have got cots, mattresses. We have a lot of it is the household waste, which is inside a plastic bag, and that is tossed and that floats because it's got air inside. And a lot of it is that. But otherwise, we get nowadays we don't get labels because someone knows that it can be read, and otherwise we get other plastic. Single-use plastic is less, but there are chairs, plastic chairs, a lot of such things we get over there.
Thank you, Shekharji. I think we've come to an end to this discussion. I know that I must mention that it's been very, very insightful. I think one of the strongest messages emerging from the discussion today is that marine plastic pollution, of course, doesn't begin right at the ocean. It's something that starts off, way before, starting from the production systems. There were questions on it. The consumption patterns, very, very important. Interventions right at the cities, streets, drains, and to kind of address this seriously, I think we need to kind of intervene much earlier, as far as the value chain is concerned. What also becomes very clear is, addressing this challenge would require a little more than the isolated approaches that we come across. Data, from today's discussion, we understand that helps us understand the scale and of course the pathways that leakage has actually happened. We've also been looking at the emerging concerns like microplastics, also technology, on how practical tools can actually help intercept and reduce the leakage on ground. But ultimately, we see that the real impact actually happens when all of these work together, and we have an integrated approach towards the larger waste management problems, also addressing policy kind of issues. So I think today's discussion has shown us both the complexity of the challenge and also the enormous opportunity that lies towards strengthening the action that can be taken to address it. With this, I would like to sincerely thank all our speakers for taking out time to be a part of this webinar, and also sharing their insights and experiences today. And also a big thank you to all the participants for joining us and being so interactive with the discussion that we had to offer today. Over to you, Akansha.
Kaushik, if I can add.
Yeah.
Yes.
Yeah, okay. We didn't discuss much about ocean plastic. I wanted to quickly come up on that.
Sure.
Is that ocean plastic, as they say, you have to shut the tap before we mop the floor. That is normal. But some of it still reaches because it's a transboundary issue. It can come from other countries. It's there. We have a plan, maybe hopefully in 6 months, 1 year, depending on the kind of support we get, on the coastline where there's a dense plastic leakage, there's a patterns. We have planned to arrest that. We have tested our ocean wave energy technology in 2018, actually, lying unused. It is still with us. We might take that because I believe we do not go with, you have to have a scalable solution. Distances are very large in the ocean, and you cannot take this to an island which is barely able to manage its own waste. So it has to all come back to the mainland, and it has to be low cost. It has to be very, very smart solution. Otherwise, you cannot put it at a scale that you want. So we might be using ocean energy, wind energy. When I say it's a good old sails, these are all things that gives you a relative motion through the water, and your sea works. So that's our broad plan. And perhaps if we get the right support, we might do it in another 6 months to 1 year. Thank you very much.
All the very best, Shekharji, for your very, very fantastic work and the plans that you have ahead. Over to you, Akansha.
Thank you. Thank you, Kaushik sir, and thank you to all our speakers. I would say that, our speakers have brought forward some valuable insights from understanding the pathways and impacts of macro and microplastics to highlighting the importance of the robust data and monitoring systems, and equally inspiring were the innovative technological solutions shared, demonstrating how, the interception and prevention at the riverine level can create meaningful impact at scale. So thank you so much for this session. And we were very glad and, honored to have you all here. And we hope that today's webinar has not only deepened your understanding, but also sparked ideas and partnerships and actions for our attendees. We'll ensure all the, unanswered pending questions to the panel. And you can connect with the panelists through LinkedIn profiles that we have shared. As I mentioned, this webinar is being recorded and will be uploaded on our YouTube channel and on our website. Please stay updated on our future events, and please subscribe to our newsletter and follow us on social media. Thank you so much and good day to all.